Bill Carwin. I'm working at Zend Technologies, and I'm the product engineering manager for the Zend Framework project. This is an open source project that I'm going to tell you about today, particularly in respect to the database layer of it. The Zend Framework is a PHP 5 class library, so it's for object-oriented programming with PHP. Specifically for web development, but there are some features that can be used in non-web application development as well. It's a free product. I've gotten some questions in the past, like, what are you charging for this framework? No, it's open source. It's being developed by open source community contributions, and it's a BSD license, so it's very friendly to usage for corporate and also open source projects. So far we have 140,000 lines of code in the library, and probably another 50% in addition to that in unit tests. We have a very high focus on unit testing and quality for this project, so it's being developed in a very professional manner with best practices. The mission for the Zend framework is to be extremely simple. That is to provide very convenient usage for common web application development needs. It doesn't necessarily do everything under the sun, but it is extensible, so if you have specific needs, you can extend the classes in an object-oriented fashion to do what you want it to do. We're currently in beta release, and we've been in early access release prior to that for a number of months, and so far we've had 182,000 downloads. I just checked the statistics this morning. You can read it. You can download it yourself at Zend.com. What's in this Zend framework? I'm going to cover some of the components. I'll just tell you about the components that are in the Zend framework, but specifically we're going to be talking about the database access portion of it. You can see that it has a pretty large laundry list of services and features that you may need in your web application projects. I won't recite them all on the list here, but you can read it for yourself. And all of these are included in the download. So what specifically is in the ZendDB component? This is the database access layer, or the collection of classes that help with database access in the Zend framework. First and foremost, we have an adapter pattern to allow a convenient and consistent way of connecting to a variety of database brands, including all the ones that you list here, that we see listed here. And notice that we have two adapters that both go to MySQL. One which utilizes the PDO library as its backend, and one which uses the MySQL set of functions as its backend. This is just to give them flexibility. I'll show you how we can use that. The adapter class has the basic create, read, update, delete functions that you would expect to have in a database access layer to be able to submit SQL queries and get back results and take advantage of that. It also has good support for quoting identifiers. We're all concerned about application security, and one of the things that we can do about that is to make sure that we don't have problems with external data creeping into our SQL queries. So quoting is very important. We have a profiler system within the ZendDB component so that you can measure the performance and the time taken for your queries that you're running. A convenient class to build SQL queries. How many of us have written a very long function in our applications that assembles a SQL select query out of strings and components of strings? It's very hard to get right. You end up tearing your hair out, or I have at least, trying to get all the clauses of SQL select square statements together, and this class helps you do that. I'll show you some examples. And finally, there's a nice object-oriented interface, a class that allows you to treat tables almost like an object relational mapping. It's very simple, so it doesn't quite fit the precise definition of an object relational mapping, but you'll see that it provides much the same value and at a much simpler level of detail. a lot of code examples. They're all on the slides, but you'll be able to see it much more easily being on the slides. Here's the basic way of connecting to a database. In PHP code, you would just require the one class, ZendDB.php, and this has a method called factory, which you can use to specify the brand of database that you're connecting to and parameters that you use as credentials and other options with which to specify your connection string. It takes care of it all for you in a manner that is appropriate for the brand of database you're going against, and it utilizes the PHP extension in the proper way to make that connection for you. The return value of this method is a class object of the appropriate adapter. In this case, I'm using the MySQLi extension to do that. Instead of using this extension, you could also use the other database brands by specifying the correct class name. The string that you specify in this argument becomes the class that it maps to. So the usage of the classes is consistent. Once you have that adapter object, you can run queries against it. For example, here's the method fetchAll, where you specify a select statement, and it runs the select query, gets the results back, and returns it as an array of arrays. This is an extremely simple way of getting query results back into your application. You can also run prepared queries this way. So you have support for query parameter placeholders, which you then use values to replace into the query parameters, just in the way that you would expect to have with other database frameworks.
Is that doing real prepared statements, or?
In this case, it's doing real prepared statements. We do have some other examples I'll show you a little bit later where it's emulating prepared statements. But in this case, it's actually doing a prepare on the SQL statement with the placeholder, and then in the execute step, it sends the values separately to the database server to the previously prepared query. So it's a real prepared statement. Very simple way to insert data. Very PHP-centered way of specifying the values in an associative array, mapping the column names to variable value strings, or you can even use strings defined into PHP variables. In this case, we have a table which has auto-increment key, so we need access to the primary key value that it generated as it did that insert, and there is a method for doing that. Updating data is very similar. Uses an update method, as you might expect. Mapping columns to new values, and also includes a string parameter which you use to specify the conditions of what they update. And return value is the number of rows affected. Of course, you could specify the array as a PHP array variable itself, which you defined earlier or build earlier. So you don't have to specify it as an array literal in this invocation. I'm just showing this for simplicity. Deleting data is very similar. You have a where expression in a string in the argument list to the delete function, and you also specify the table name. It also returns the number of rows affected. So this is as simple as you can make it, to be able to create, read, update, and delete operations against the database by specifying things in a very structured way using PHP methods. Another value that this adapter class gives you is there's a describe table method. You just give it the name of the table you want, and it returns to you an array of information that contains metadata about that table. This is on 2 slides, so bear with me for a moment. The array that you get back is indexed by the columns in that table. So each of the keys is a string, which is the column name. The values in this array or further arrays, which gives you more information, metadata about the table. I'll show you that in the next slide. Here's one of them. See why this is on one separate slide, because it's quite a bit. There are keys, table name, column position, etc., that give you all this information broken down in a structured way so that you can use it in your application if you need it. And of course, this array goes on for all the other columns in the table for which you inquire about metadata. I'll make a special note of the last two elements in that array, primary and primary position. Primary is true if the column for this particular entry is part of the primary key of the table. And in case you have a primary key which is more than one column, the primary position takes into account and tells you, is this the first column of the primary key, the second column of the primary key, etc. In many cases, the primary key is only a single column, but certainly SQL permits multi-column primary keys. Let's move on to quoting. This is important when you want to interpolate strings and variables into your PHP and make sure that you're not going to break your SQL syntax because, for example, one of your identifiers and values contained a quote character. We've all seen that in many examples of how that happens. The example that everybody sees is the word O'Reilly, which contains an apostrophe. And of course, this would cause an imbalance in the quotes for the quoted value in your SQL expression. So this function, quote, allows you to interpolate that safely. Notice that unlike the MySQL real escape string, which is another function provided by the PHP extension for MySQL, this returns it in a slightly different format. The quote method in ZendMySQLbig returns it with quotes on either side, instead of just the quoted string, which you then have to put quotes on the other side. There's another convenience method called quote into. This is the example of the emulated parameters, where it's using the question mark as though it looks like a parameter, but it actually does the value interpolation in PHP code before it completes the SQL query. So this just takes that value in the second argument to the quote into method, the O'Reilly string, interpolates it into your expression as the first argument in place of the question mark. And then you can use it in your SQL statements safely. Quoting values is fine, but we also need to quote identifiers. One of the goals of the ZendMySQLbig component is to work with special cases as much as possible. For example, if you have special characters in your table names or column names, you may need to quote them as identifiers using the SQL syntax appropriate for the database you're using. In MySQL, we're all familiar with that. It's the backwards apostrophes, the backticks. You put those around a table that may have special characters or white space in the table name, or international characters, or other characters that wouldn't be valid for a normal identifier. This method, quote identifier, is very similar to the quote method function, but it is specific for identifiers, so it knows to use the backticks in the case of MySQL, or the double quotes in the case of most other database spreads. Another great feature of the ZendMySQLbig component is profiling. This is simply measuring how many seconds it took for your SQL queries to run, and then you can get that back in a report at the end. Most of this is useful for development and debugging. The overhead of doing this is very light, but still you may not need to enable this during a deployment situation. But still, the database adapter object has a profiler object as part of it. It's just disabled by default. It's not going to actually record any of those timings unless you specifically enable it. After you enable it, SQL queries are going to be measured. It just takes note of the time when it began and the time when it ends, and then the information is available to you later. For example, let's see this code, which just tells you the longest running query. suppose you enable the query profiler, and then you run some number of queries, each of which is recorded by the profiler and times are measured when those queries began and ended. And then subsequently, you can get a list of all the query profiles that it recorded and the timings for each of them. Loop through it, find the one with the greatest value for the elapsed seconds of the query, and that's the one that turned out to be the longest running query. The profile also has some features to allow you to filter things out. It will record profiles and timings for statements that you choose to filter out. And you can specify those with these methods: filter query types or filter elapsed seconds. So you can omit things from the report that were very fast anyway. You may only want to know about the ones that were taking more than 5 seconds, for example. And then subsequently, you can filter the report further by specifying a value corresponding to the type of query that you want to see the report about. So even though they have collected data about select and update using these constant definitions to specify them, you only want to see a report of a subset of those. All right, here's the class for building a select query. This is really useful if you want to build queries in a modular fashion based on application logic. You can put together the clauses of the select piece by piece using separate methods for each of the type of clauses. In this case, we create a select object with this method off the adapter, which is just called select. It gives you back an object which you can then call methods on, for example, from. So you specify a table that goes in the from clause of that select, a where clause where you can give a pair of arguments. One, they're just meant to be quote into method that we saw earlier. The first is a SQL expression. The second argument is a value to interpolate into it, replacing that question mark. Then you can execute it. We saw the catch-all method earlier, but in this case, we're actually feeding in not a string, but the object of the ZendMySQLbig class. The adapter knows to look for this type of object, and it will turn it into the equivalent SQL string using that underbar toString method. Or you can also call that deliberately yourself and take a look at the SQL string representation that you have so far as you're building it up. This class also supports a fluent interface. That is, most of the methods of the class return the reference to the object itself. A lot of people like the fluent interface, and this just allows you to code it in the manner that you find most appealing. You don't have to use the fluent interface. In fact, you can mix the fluent interface and the traditional type of usage where you call the functions individually. And I've shown an example of that down below. In this case, we also see that I can put in those clauses in a manner that's not the same order as they would appear in the SQL at the end. You can add clauses that would go into the middle of it. It takes care of it all as it does the toString method to render. There are quite a few other methods to this select class. I'll show you a few of them. We have methods to apply distinct clauses to specify columns. By default, it will just select star for the tables that you mentioned in your from and join methods. But you can also specify an array of the columns that you want to see from those tables, so you don't have to get all the columns. You can specify table aliases, or what are termed correlation names. And then you can use those correlation names in other clauses of the SQL. You can specify SQL expressions, otherwise they are going to be treated as column names and quoted appropriately for the backticks. In this case, we use count star. The way this works is it looks for the parentheses. So if you have column names that contain parentheses, things are going to get a little bit tricky. But we've assumed that most people don't actually have parentheses literally in the names of their columns. So also give aliases to columns. And we'll see that example down below. Here's an example of it's naming a second table for this select query using a left outer join, and specifying that also with a join condition. The p.report by equals a.account name would go into the on clause of the join. Note also that's using the correlation names that we defined up above. And finally, group by clauses, having clauses, order by clauses. You can store ascending and descending in there, and this is them, and limit clauses. Notice that we even made use in that having clause of the column alias that we defined up above. All right, moving on. This is the object-oriented interface to tables and rows that we have built into ZendMySQLbig. It's a very lightweight version of an object relational mapping, and it gives you a lot of flexibility at the same time being very simple to use. Based on design patterns that are in Martin Fowler's book, Patterns of Enterprise Architecture, and you can see that it will give us the usual operations for creating and operating on rows, but also it has some pretty powerful ways of fetching rows from the table and from also related tables. I'll show you some examples. How do we use this? Start by defining a PHP class for each of the database tables from which you want to access it using this class interface. In this case, I do it in 3 lines, or 4 lines if you count the braces. All I have to really specify is the name of the table as it appears in the database, and create this class which extends the abstract class for the table data gateway. That's it. All the other code is defined as an abstract set of logic in the base class of that the ZendMySQLbig table abstract. It knows how to find the metadata and the primary key information from the table. It knows how to do CRUD operations, etc. I'll show you some examples of using them. To create an instance of this class, we have to give it a valid connection to a database, which takes the form of an object that we saw earlier, the adapter class. Once we have that adapter class object, I'm calling it $db as we saw earlier in the presentation, there's a static method set default adapter. This sets the adapter that is going to be used for all the table instances in our application. But you may have an application that connects to more than one database, perhaps more than one brand of database. You could actually write an application that connects to a MySQL database and fill in the blank, Oracle, Microsoft, etc. So the constructor for the table class that you create actually takes as an optional parameter the instance of the adapter, so you can connect to that previously and use that to override the default. Why all this plumbing? Well, we want to make it so that it's easy to use, but we also want to be conscious of security so that we try to isolate the cases where you're actually specifying things like the password and the credentials by which you connect to the database in a single place, so that we can take advantage of that and also provide security as much as possible. Once you have this instance of a table class, you can do a fetch all on it. This is very similar to the fetch all that we saw earlier from the adapter, but in this case, it knows which table to go to. All you have to specify, optionally, is the where clause of which rows you want to fetch. So in this case, I'm getting all the bugs that have a particular status. What it gives you back is an object which is called ZendMySQLbig table row set. A row set is just a collection of rows. The row set is iterable and countable, so you can use it almost like it's an array. And I showed at the bottom of the slide, using that row set like an array in a for each loop. It iterates over the row set, gives you back your row objects. This is another object. And the row object, in turn, has access accessors so that it can give you an access to each of the columns in that row as though they are properties of the object. Question?
So what's the type of the row object?
The type of the row object, the class name is ZendMySQLbig. And the row set is also ZendMySQLbig.
But how do so the class, so if you have common code, you just see that provide you like what the idea of classes.
The class behind the scenes that gives you access to that is using a PHP magic method that allows you to access things by name, even though those don't exist as real properties per se in the object. But it knows, it has a set of the data for one row, and then maps what you ask for into that array. But it does give you a nice convenient way of accessing them by name. There are sets. I'll show you an example. But first, there's a method find, which is a little bit like fetch all, except instead of having to specify a whole where clause, you just specify the value of a primary key or multiple values. You can give it an array and it will return multiple rows corresponding to the values you give. Unless there are no rows in the database table corresponding to the values you give. So in this case, I say that row set 1 in the example is 0 or 1 row. You may have asked for a row that doesn't exist. What it gives you back as a return value of the find method is an instance of that row set object. And since you can treat it like an array, you can use functions like count on it. You can say, does this row set contain any records, or is it an empty row set? Use the count method that's in PHP with the row set object as the argument, and it looks like an array access. If you have a composite primary key, you have to specify those defined method as subsequent arguments. So you would say, if your compound primary key were 2 columns, you would have 2 arguments in the argument list of the find method, and it would map each of those to the respective columns in the primary key in the same order that they exist in the database. No, in the second example, you would have to have 2 arguments to the method, each of which is an array with the same number of arguments. The problem with doing what you just described is that how do you tell the difference between an array of multiple primary key values for a primary key which has 1 column versus a multiple values, sorry, that's the same example. Exactly, yeah. So we had to do it that way. If you had a compound primary key, 2 columns, you'd have to have 2 arguments to the method. Each argument would be either a scalar, if you're just looking for 1 row, or if you're looking for multiple rows, you'd have to specify an array for each of those arguments. The arrays would have to have the same number of elements, and they have to be the order that you want them to be looked up in. Update. Here's more of our threaded operations. In this case, we find a row using the find method. We get one of the rows out of that row set. You're using the function current in this case. That's part of the iterable interface that allows us to just say, give me the one I'm looking at currently. In this case, the row set probably has 1 element, so current just means the row that's in the row set. And then we can access those columns in the row in a way that sets the values instead of reads the values. So this is to answer your question earlier, are there setters? Just set it to a PHP scalar value. Here's a new string we set it to, and then call save. The save method creates the SQL update statement, posts it to the database, That's it. Very similar to usage in the insert method, except in this case, you need an empty row. You need something to start with. So there is a method, fetch new, which doesn't actually fetch anything from the database. It just creates a row object which doesn't have any values in it yet. Then you can set those values using the setter interface. Call the save method. It knows that it's supposed to generate an insert statement instead of an update statement, post it to the database, and that's all.
So does those methods run exceptions?
Good question. Good question. If you didn't hear it is, do these methods throw exceptions? Yes, they do. Because, for example, you could specify values that violate constraints. So yes, they do throw exceptions. The exceptions take the message from the underlying database extension, which in turn takes the message from the RDBMS on the back end, saying you violated a not null constraint, for example. So yes, we should probably wrap these functions in try-catch blocks to catch the exceptions and to recover from the grace point. Delete, very similar. In this case, we grab a row from one of our queries and just use the method off the delete object, the delete method off the row object. Pardon me. Okay, now things get interesting. What if you have multiple tables and you want to access them through this interface? Let's take it, for example, if we have in our example database, bugs can be reported by an account. Somebody filed this bug. So we have a many-to-one relationship between these two. In our example, we want to get the account for me, Bill. So we use our find method to look up the row corresponding to that. I'm assuming that the primary key is a string in this case, so I'm actually looking it up by string, Bill. And then I can just say, find bugs. And it knows to look up a row set from the bugs table, where the values in that bugs table reference the current row that I'm looking at from the accounts table. That is, the foreign key in the bugs table contains values that reference the primary key in the row object that I'm currently looking at. Pretty cool, huh? You do not need to have a foreign key, and I'll show you why. But just to complete the example, you can also go the other way. You can get the parent row if you have a row from the dependent table. If I have a row from the bugs table, I say find parent accounts, and that gets the corresponding referenced row from the accounts table. Okay, how does this work? Well, based on the example we saw earlier, you already have these very short classes for which you define the class relationship to the underlying database table. And all these do is define the name of the database table in that property. So what you do, just press spacebar because the mouse isn't working. And you declare this further syntax, which I call reference map. And that gives you the ability to specify the columns in the dependent table, bugs, and the class that it references. You use the class name, so it knows to look up that object in your library of class table classes, and looks up the relationship that way. So this is a declarative way of specifying the relationship. You don't have to write any code, you don't have to override any methods or implement any functions in the class. It's purely a data declaration that you put into each respective dependent table class. You don't have to put anything into the parent class. So when you do a lookup, if you're looking up a dependent row, you say, I have a parent row, I have an accounts row, and I'm looking at bugs. It says, bugs. We have a class called bugs. I'm going to go to the bugs class and look up the reference map, and now I know which table to go query. If I'm going the other way, I have a row from the bugs table. I have the reference map, and it references the accounts class. So I go to the accounts class and look it up based on that table map. That's just a description of what it's doing behind the scenes. You don't have to worry about that. You just use those find methods that I showed. You can also customize these classes. You can add more methods in your subclasses that extend the behavior of the base abstract table class. For example, in here, I'm overriding the insert method that I would have on a table class, so that I can do something like set the created on field. Created on field may be a timestamp, so that as I insert records into this database, it always has a correct value in there. In this case, I'm only doing it if you haven't specified a value, but you may want to actually enforce it. There's all sorts of different ways that you would want to implement this based on your application logic. So this gives you the opportunity to do that. And then following that, setting the values in that data array, the mapping between columns and values, it then calls the parent class's method of the same name, which takes care of the insert. Just to recap, then we can go to further questions. We talked about the adapter classes that provide low-level thread operations to the database and allow you to connect in a consistent fashion. We talked about quoting issues and the methods that are provided to perform quoting. The query profiler, which allows you to get very simple reports of how long it took in seconds for the different queries that you've run. We saw some examples of the select query builder, and we saw the table data gateway and row data gateway that provide a very simple object relational mapping-like solution. Very good. And again, you can download it from framework.zen.com. That's the end of the presentation. I'll be glad to take questions if we have about 10 minutes.
So does the framework provide an interface for stored procedures?
That's a good question. The question was, do we have any interface for running stored procedures yet? We don't have that feature yet specifically in the ZendMySQLbig classes. And you can imagine that there are some nuances to that, because stored procedures not only take input parameters and have return values, but they also provide return parameters. That is, parameters can be set within the stored procedure. Right, sometimes stored procedures have multiple result sets. Stored procedures vary greatly in their implementations from different brands of databases. And one of the goals of the ZendMySQLbig component is to provide a consistent interface to multiple RDBMS brands. So it's going to be a little complex and require some refined design decisions to understand how to support all the capabilities of all those different databases. That will be phase 2.
We have replications of distributed reads. Does this have anything to do with it? Let's go and play
I'm sorry, I didn't hear that.
We have replications, we can distribute our reads. Does this have anything built in? So select goes to one place and insert gateway goes somewhere else?
No, the question was about replication and load balancing. I assume that is, can this framework automatically balance your queries and run them against multiple backends? We don't have anything specific to that, and in fact, that's deliberately by design, because some of the RDBMS brands are starting to do cluster support at the server level, so that you would connect to a resource, and then it takes care of doing load balancing as part of the RDBMS backend. MySQL doesn't have that yet, but it's coming. And some other databases like Oracle already do have that. It's really a way of, it's better to be handled in the backend, and the result is that your application code is a lot simpler that way. Anybody have any questions? Yeah.
Have you done any profiling of the performance of the different, of the Zen Framework DB classes versus the other active record tools out there?
Question was about profiling ZendDB versus other active record implementations or form implementations. No, we haven't done any specific benchmarking about that. We're really hoping to get our implementation done and ready before we start addressing that. But really, the amount of code that's in the ZendDB is very lightweight. I can imagine that the overhead of this versus just using the database extension library directly would be pretty minimal. Other questions? Yes?
Where are we heading after 1.0?
The question is, where are we heading after 1.0? There's a number of different things that we could add to this. The stored procedure support would be a good example. There are other examples of things we could do to make the fetch and find methods in the table class more robust and flexible, so that you could do things like specify ordering criteria or more criteria for performing various SQL clauses against the operations there. There may also be opportunities for expanding the table relationships support. There are other numerous examples of things that you could do to support value in each individual database branch. For example, MySQL has their management and optimization interface, so that may be an opportunity there. But this is an open source project. There are certainly lots of ways we can expand on that. And in fact, the Zen Framework has a robust system for accepting proposals. If somebody in the community wants to work on a given feature, they can write a proposal, we can review it, other members of the community can comment on it before we actually get to writing code about it. And that's a really good way of embedding the types of things that we're going to grow in the future as far as new features and new components. So if you want to learn about it, get involved. Look at framework.zen.com.
Is there any proposal of writing any kind of form engine with
Oh, the question is about form engines and trying to have some kind of framework support for handling forms for a web application. We have a number of proposals about that, but we're still evaluating some of the options there, and we're also waiting on some other developments before we adopt a solution for that. So currently the Zen Framework doesn't have a robust way of handling the life cycle of a form. But certainly that's an area that we see as important for web application design. We'll be expanding it there in the future. Okay, I'm almost out of time. Any last questions? Great. Thanks very much